So welcome everybody to this latest video on 162 Maths, and in this video we'll be looking at A2 trigonometry with a focus on solving trig equations involving cosec, sec and cot. Now when solving a trig equation involving tan, sine or cos, your aim before solving was indeed to make cos theta, sine theta or tan theta the subject before using the inverse functions to work out the value of theta within the given range stated in the question. Now when working with cosec theta or sec theta or cot theta, the principle is exactly the same. So again, you want to make those the subject, and then obviously using these conversions when you have made it the subject to then find the values of theta or x, whichever it comes in. And these are definitely some ratios that you will definitely need to learn and will need to remember. So as always, let's have a look at some example questions. So in this first question, we've got cosec x equals 2. Now again, what we want to do is always make sure that we're reading the question carefully, and we're wanting x as a value between in degrees. So again, we're working in degrees, so whenever you're using your calculator, we need to make sure it's in degree mode, and we're looking for angles that are between minus 180 to 180 and also to 1 decimal point. So looking at the first question then, so what we want to do here is we've got cosec x, our subject, which is our main point that we want to do. Now with this, what we then want to do is convert this. So from this, we've got that cosec x is going to be 1 over sine x equals 2. And then again, once I've done that conversion, I then want to make sine x the subject. So I take the 1 over to the side, so I've got sine x equals a half. Now from this, I can then use my calculator to do the inverse sine of, or the inverse function of a half, and that gives me a value of our first angle, which is 30 degrees. Now with this, what you then want to do is think back to your graph, or you can use the cast to try and work out what the other angles are going to be. So the sine graph looks something like this between the ranges that we're looking at, and where we're looking at a half, that's going to be these values here. So I'm looking for this angle and this angle here. So to find the next angle, it's then going to be 150 degrees, and these are my two angles. Now it's also worth just checking to make sure that when you do your graph, make sure it's within the range that's given, so you can see how many angles you can look at, and you can also look at test the validity of those angles as well. So moving on to the second one, we've got sec x equals 3. So again, what I'm going to do is I'm going to convert, once I've got sec x the subject, I can then convert that as 1 over cos x equals 3. Then make cos x the subject, so I've got cos x equals a third. Then I'm going to do exactly the same, so x equals the inverse function of cos of a third, which gives me my first angle, which is going to be 70.5 to 1 decimal point. So if I then draw my cos graph between those ranges, and so here we're looking at something that looks like that. And where we've got a third, so that's looking at these two values here. So then I'm looking for the next angle, which again with the cos graph it's going to be symmetrical, so I'm also looking at 70.5 as the first angle, so the next angle is going to be 70.5 degrees. Now I could easily write the answer as plus minus 70.5, and there we go as our second answer. So moving on to our third question, so here we've got 2 cot x equals 1. Now here I want to make cot x the subject, so I'm going to take the 2 over to the side, so I've got cot x equals a half, and then I can convert the cot into tan equals a half, so I've got inverse tan of, and it's going to be tan x equals 2. So then doing the inverse of tan of 2, which equals x. And so x equals, and for my first angle using my calculator, is 63.4 to 1 decimal place. Then using the graph, in which I get something like that between my 180s, like so, and 2 is going to be looking at here. So my second angle therefore is going to be minus 116.6 degrees, and there is my second angle for that particular question. So now let's have a look at these next three questions. So these ones here, well, the first thing to notice is by reading the question carefully, it's to solve each of the following equations from 0x to 2 pi. So therefore we need to make sure that our calculator is in radian mode. And we also need to make sure that we acknowledge the fact that we're wanting answers to 2 decimal places. So for the first one, we've got sec squared x equals 4. Now again, what you want to be thinking straight away with these types of questions is you want to make sec x the subject. So here we've got sec squared x, which is, now this is just another fancy way of writing this. So the first we need to do is square root. So what we've got is we've got sec x equals, and then we've got plus minus the square root of 4. So sec x equals plus minus 2. And then we can then convert it, once we've got sec x as the subject, to 1 over cos x equals plus minus 2. So therefore cos x is going to equal plus or minus a half. Now with this, what we need to do is we need to break this up into 2 separate questions. So here we've got cos x equals, and we'll go for minus a half. And we've got cos x equals a half. So solving this first one of equals minus a half, where we get our first angle in radian mode as being 2.09, and then our second angle therefore being 4.19. Then working with cos x equals a positive a half, we get an answer of 1.05 on our calculator and 5.24 as our second values. And again, this is kind of relating back to the cos graph, which looks like, not like that, because we're working from 0 to a half, not minus 180. So for this, we're looking at a graph that looks like this. So here we're looking for where it was a half, looking for those values, and where it was minus a half, we're looking for these 2 values. And again, if you are using the graph rather than the cast method, it is important that you do recognize that this point here is going to be 3.14 and this value here is going to be 6.28, just so that you get gauge an idea of, basically that's where it should be, not there, get rid of that. And so just so you get an idea of the validity of your answers when you are finding them, and so you get an idea of where it should be. So for example, with the yellow line, we're looking for a value that's going to be less than half pi and more than let's say 1.5 pi, and likewise for the other values. So those answers there we've got are completely and utterly valid. So moving on to question 2, so let's just move that over there. So here we've got cot squared x equals 3 cot x equals 0. Now there is a key thing that a lot of people here would do with this. So some people what they would do is take the 3 cot x over to the side, and then they would divide both sides by cot x. Now in theory we can't really do that, because generally speaking within this given range that we've got, cot x could equal 0. So therefore we can't cancel things down by dividing by cot, because obviously technically you could be then divided by 0 within that given range. Now this is also possible, and this tends to move on to proof questions. You can divide by the trig ratio as long as it doesn't equal 0. Now in a question, if it does say that x cannot equal cosec or whatever, can't equal 0, then you can divide by it. But if it doesn't say that, like it doesn't say in this particular question, then this is something that you cannot do. Now the importance of doing this is because you're going to miss out on a couple of values. Now if you are given in this situation where it doesn't quite look like a quadratic, we'll move on to those questions in due course, what you want to do is you want to factorize. So both the 2 terms in this particular expression have got cot x. So what I've got is I've got cot x plus 3 equals 0. So now here what I've got is I've got 2 potential terms that have been multiplied, and each of those 2 things could equal 0. So here I've got cot x equals 0, or cot x plus 3 equals 0. Now when looking at this, now you might think to yourself, well okay, let's convert this. I've got 1 over tan x equals 0, which is correct. And then you think, oh right, let's take the tan x over to this side. Now the problem with this is the fact that obviously when you multiply by 0, you're going to end up with 0, and therefore 0 can't equal 1. So this is where it comes a little bit more sort of invalid. Now what you want to do is kind of refer back to the cot x graph, which we showed in the previous video, and you can see that there are actual values that do exist. Now you can't obviously work this out on your calculator, so what you'd have to do is either use cast or use the graph to work those values out. Now cot x equals 0 is going to be valid, and it does give you numbers of 1.57, which is half pi, and 4.71, which is 3 over 2 pi. So there are our two values for that. Now, obviously, in terms of units, you don't need to write degrees. You don't even need to write the R. Just the actual values would be absolutely fine as long as you're giving it to the correct sort of rounding that they are wanting. Now, for the second set of values, this one's a little bit more similar to what we did previously. So I've got cotx equals minus 3. So I've got 1 over tan x equals minus 3. So then I've got tan x equals minus a third. Now, do you need to write all of this down? Yes and no. In some aspects, I've found that a lot of students, when they get to this stage here, they tend to get the reciprocal and they reciprocal it twice. And that's where the errors lie. So make sure that your presentation is on point and make sure you are getting these questions right. Now from this, I can then simply type that straight into my calculator. So I've got the inverse tan of minus a third, and that gives me a value of 2.82. And then using the graph, it gives me a second value of 5.96, and so there are all my values. Now when it comes to exams, I would recommend that you do write your answers in a clear neat row, so they don't have to be in numerical order. So what I would recommend that you do is write 1.57, 4.71, and then 2.82 and 5.96, and there is my final answer. Now if you were to write it like I've set out here, then it may be just a case of just highlighting. But personally, if you can spare those couple of seconds of writing your answer a little bit neater, it just makes it easier to mark for whoever's marking your work. And generally speaking, I'm not going to lie, but if they see the correct 4 answers or the correct 4 angles or values of x, they're not really going to look at you working out. So that's where the marks will come, because obviously those answers can't be picked up through thin air. They would be established by using your calculator and using the correct methods. So moving on to question 3. So here we've got a combination of secx and cosec. Now for this, again, what you want to try and do is get all the trig ratios the same. So here I recognise that secx is basically 1 over cos, so this then becomes 3 over cos x plus 11 equals 4 cos x. From this, what I then want to do is multiply everything by cos, so I get 3 plus 11 cos x equals 4 cos squared x, and then this then slowly turns into a quadratic. So I've got 4 cos squared x minus 11 cos x minus 3 equals 0. Now you can factorize with regards to this. So for example, I could write 4 cos x, and it's going to be plus 1, and I've got cos x minus 3 equals 0. Or you could convert it, so you could write it as, like if you wanted to, you could let y equals, let's say cos x, and then what you'd end up with is 4y squared minus 11y minus 3. You can then convert it, use your calculator to work it out, find the values, and that'll be absolutely fine. So from this, what we then got is our 2 possible values. So from, let's go on to solve this. So looking at this one here, I've got 4 cos x plus 1 equals 0. So I've got 4 cos x equals minus 1, and then cos x equals minus a quarter. Now from this, I can then go on to solve that and find the values. And again, we're working in radian mode. So using my calculator, I get my first value on the calculator being 1.82. And I'm using the graph forecast to find the second angle. I get 4.46. Then looking at the second bracket, so I've got cos x minus 3 equals 0, and I've got cos x equals 3. Now for this, there are no solutions. There's a math error from this. Now this is a really important thing that you do, is make sure you write no solutions for this particular angle. So these two answers of 1.82 and 4.46 are the only valid answers within that given range that they're giving me in this question. And for these two examples here, so the question says solve each of the following equations, and again we've got a different range this time. We've got 0 to 180 degrees, and we're rounding to 1 decimal place. Now again, looking at the first question of 2 plus 2 cosec, or I should say 2 plus cosec 2x equals 0. So again, what we want to do is, now here we're dealing with a double angle, which I want to use that term very loosely because it's another topic in trig that we'll move on to next. So here what we want to do is want to make cosec 2x the subject. So first thing I'm going to do is take the 2 over to the other side. So I get minus 2. And then from this then becomes 1 over sine 2x equals minus 2. So sine 2x equals minus a half. Now from this, if I then do the inverse, I get 2x equals the inverse sine of minus a half, in which then I get 2x equals, and then looking at the angles, I get minus 30 degrees, and then using the graph, so in terms of the graph which I've got, which looks like this, and so it's giving me this value here, so it's these values that I've found, and so the graph, the calculator only gives me the closest to the origin, which is this number here, so I can then find out what those two angles there are going to be, which are going to be 210 and 330. Now from this, what I then need to do is need to find out what x is. So here I need to divide everything by 2, so I've got minus 15 degrees, 105 degrees, and 165 degrees. Now obviously the minus 15 doesn't fall within that category, so I can't include that in my answer, so I'm going to take that off and then underline the two valid answers I have there. Now looking at question 2, I've got sec x minus 50 equals minus 3. So again, what I want to do is do the convergence. I've got sec theta, or in this case we've got x minus 50 as our subject, so that's absolutely fine. So I've got 1 over, and it's going to be cos of x minus 50 equals minus 3. So cos x minus 50 degrees is going to be minus 1/3. Then obviously finding the values of this, I get minus 1 x minus 50 equals, and again from this what I'm going to then do is x minus 50 equals inverse cos of minus 1/3, which then gives me these following values. So it gives me 109.5, and then the second angle is going to be 250.5 degrees. Now again, this gives me x minus 15, not x, so they need to add 50 to each of these angles to get rid of this, in which what I then get is 159.5 degrees and 300.5 degrees, and there is my final answer.